Okay, good morning. So we continue the lesson operations on sets. So if you remember, we talked about three operations: the complement operation, which applies on one single set. Do you remember what was that? So A complement, if A is a set, A complement is defined to be the set of all x's where in the universal set, but x does not belong to A itself. That was A complement. And then we talked about the union of two sets. If I have two sets, A and B, I can union them. This is the symbol we use. Do you remember what was the definition? It was the x's where, of course, they should be in the universal set, but that x is either in A or in B. And I also mentioned that in mathematics, when I use or, that's an inclusive logical or. It means that this one or not that one, this one or not this one, or both. So that's the meaning of a logical or. And then we also had this operation which was called intersection of two sets. That was the set of all elements coming from the universal set with the property that x belongs to both of them simultaneously. This is or, this is and. Yes, and then of course we talked a little bit about the properties of these operations. So we learned that both of these operations are commutative, both of them are associative, and we also learned something interesting, that each one of them is distributive over the other one. We didn't prove them, but intuitively we checked one of them with the Venn diagram. I don't remember which one was that, but the last thing we discussed was that if I have A, and if I have B, and if I have C, and I want to intersect these two, for example, and then union it with A, this can be done in a distributive way, meaning that A union B, and then A union C, and then intersect them. So this means that I am distributing A union over the intersection. And similarly, you should be able to convince yourself that this is also the case. A intersection B union C is A intersection B, and then I have union A intersection C. So this is the last thing we discussed about. I don't remember which one, but we convinced one of them. We convinced ourselves with one of them using the Venn diagram, and the other one is also similar. At this level, probably that is enough, but that is not a rigorous mathematical proof of it. Okay, the next rule that I want to discuss about are these rules. These are called absorption rules. So it means that this is very similar to the... And by the way, one thing that I want to mention, whenever you have distributivity, for example, in numbers, when you say A dot B plus C, from left to right, it is distributive. But because this is equality, whenever you need, you can go from right to left. When you go from right to left, you usually say that I factored A out, yes? So distributivity and factorization are actually more or less the same, yes? If you go from left to right, you are distributing it. If you go from right to left, you are actually factoring A out. You can do the same thing here. So you see that I have two pairs of brackets, including a union, a union. If I go from right to left, it seems that I am factoring a union out. Okay, so I can factor a union out. What is left is B intersection C. Here I am factoring A intersection out, and then what is left for me is B union C. So in one direction it is factorization, in the other direction you can say it is distributive. Okay, but the main difference here, do you remember, it was Boolean algebra? The main difference here in that case and that case was that this is true, the other one is not true. The multiplication is distributive over addition, but addition is not distributive over multiplication because this is wrong. If this was the case, then of course I would say that addition is also distributive over multiplication, but this is not the case. But for union and intersection, both of them are actually correct. Okay, now about the new rules. So what happens if I have A, and then, for example, by the way, let me just do some example here about the algebra. I haven't seen the exercises like this in the book, but they are actually not hard. For example, if I give you A, and then I give you union, and then I give you A complement, and then intersection with B. Okay. I ask you to simplify this, for example, or do some algebra on this. So what happens, you can compare this formula, this expression, with the right-hand side of this formula. You see A is playing the role of A, union, but A complement is playing the role of B, B is playing the role of C, and everything is the same. So I can distribute this inside. Yes, what happens? I told you that is at this level, this is optional, but it is not hard to see how it works. I take this one and distribute it here. Yes, and then I would say intersection A union B. Yes, so if you ask me what I did, I would say that I used distributivity here, and I got this. But hopefully you remember, because I remember I was asking these questions from you and you yourself answered that. But what happens for this one? A union, A complement. I don't know anything about A, but do I need to know anything about A to be able to answer this? Yes?
No, because you can conclude that it's the universal set.
That's always the universal set, yes? If you have a set and you have its complement and union them, definitely it becomes the universal set. So instead of this one, I can go further and write the universal set, and then intersection with A union B. Okay, can you tell me what is the result of this one now?
It's still the universal set.
No, because this is now intersection. So let me ask you this question. We had this before. If I give you a set, whatever it is, it doesn't matter. If you intersect this with the universal set, what will happen? Just imagine, the universal set is that big box, rectangle, and then you have a set, but you know something, whatever set we have, it should be included in that rectangle. That's the definition of this one. So assume that this is my rectangle, the universal set, and then I have a set. I don't even give it a name. If I take this one and this big rectangle and look for the intersection, means overlapping parts, what do I get? Yes? No, a subset more than that.
Can you say zero?
No, why zero?
Nothing?
No?
Empty? I don't know.
No. It's not empty. I mean, probably you're confused completely. Where is the overlap of this and the big rectangle? The overlap of this curly thing here and the rectangle. Where is the overlap?
The AUB.
This one.
Yeah.
That's the overlap. Isn't clear? I don't know. So Mondays you're confused. So if I have U intersection C, means I am looking for those points which include both to U and C. Where are they? Isn't it clear? Not? No, why not?
I don't know. I think I missed the last lesson, so I'm not really.
Okay. So intersection means the places which is actually, so intersection means overlap. If I want to say a very simple word for that, it means that I have U and I have C. I want to look at for the overlap between this rectangle and this picture here. The overlap is exactly this one. Okay, so we had this before. If I have the universal set and I want to find the overlap of the universal set with any other set, what do I get? The set itself. So that's the correct word. So this is the universal set, and I have a set. I don't care what the name is. I want to find the intersection of the universal set with some set, and then the answer is the set itself. So do you remember? And so this is the algebra in sets. I started with a little bit more complicated expression. I used the rules, and I simplified this expression, and that I reached to this one. So this is very good exercise, by the way. We are exercising to simplify expressions involving sets using set algebra. But I know that this is not in your book, but I mean this is not hard at all. It's very simple to understand this. For example, let me ask you to simplify this. What we can do? For example, I would say A union B intersection A union B complement. How can I simplify this? So I mean that if you study a little bit higher level, this is what you need to know, how to simplify expressions involving sets using the rules and the properties. So do you think any formula on the board will help us to actually simplify this? Yes?
A intersects B union C.
A in this one?
Yeah.
No, because it's not similar to that, is it?
I was thinking you could denote A as AUB, and then continue.
Yeah, that's okay. In that case, you are right. But this is not my intention. That's why I didn't understand what you said. But your intention is correct. That might work. I don't know. So you are giving the role of this A to the whole expression. Yeah, that's completely good and okay. Okay? No, but I was thinking that I want to tell you how to factorize in sets. Yes, can I factor something out from these two? Because I told you that these two, you need to understand them from both directions. From this direction to this direction, you distribute, and sometimes you are able to factor something out. Is there something that I can factor out? But you need to understand, so this is a union, and this is also a union, and the sign between them is the opposite. It is intersection. So that is, everything is ready. If you compare that expression with that expression here, A union is the same, B is also the same, but C is being played by B complement. Yes? So then what can I do if I want to simplify that? Yes?
A union.
You can factor A union out, yes? And then you open a pair of brackets, you factor A union out, what is left? B intersection with B complement, yes?
But that is the universal set.
No, be careful. This is intersection. Don't get confused. Union and intersection are different. What is the overlap between a set and its complement?
Empty set.
Empty set. So because B complement means exactly those elements which are not in B, and now we want to overlap them. So this is the empty set. So this means that I copy and paste A, I copy and paste the union, but B intersection B complement is what? The empty set. And then A union the empty set. If you append the empty set to a set, what do you get? The set itself. Yes, so it becomes. So I mean that's also fun, you see. So you were able to simplify this expression. So this expression is more complicated than A, but they are equal. So this is called a set algebra. We are not going actually to discuss about these things that much. They are not in the book. So you need to be able to convince yourself using Venn diagram that this is true. Okay? Is that clear? Okay, now let us go and then talk a little bit about other things. So we have another rule very similar to the distribution law, but one set repeats itself. So what does it mean? It means that, for example, I have A, and then I have union, and then I have A again, intersection with B. So you see, it is very similar to this one. The only problem is that B is now A, C is now B. Yes? So another one, I can just write the dual of this. Dual means change intersection to union, union to intersection everywhere. Okay? So this becomes intersection A, union B. Okay, I want to first tell you that if you use this distributivity here, you get something correct, but it is not that useful. Let us check it out here. Okay, can you tell me what to do? For example, assume that I want to use this rule for simplifying the first one. So A union A intersection B. Okay, if I want to use this rule, what should I write? Okay, say something. Yes, what should I write?
A union B.
A, no, because this is not B. B is now A. Do you understand what's going on or not?
Yes.
Yes, okay. So A union A intersection B. What should I write?
A union A.
A union A. And then? Intersect
A union B.
A union B. So this is completely okay. But then what I can go further a little bit, because I hope that you remember the last lesson. Oh, you don't need, by the way, remember the last lesson. You have a set, you union it with itself. If you understand the notion of the union, it's a matter of seconds to understand what will happen.
A.
It becomes A itself, yes? So A union A is just A, and then you have A intersection A union B. So I hope that you see, if you ask me if this is true or false, I would say yes, this expression is exactly equal to this expression. Yes, but I was not able to simplify it that much. What I did, I just interchanged the role of intersection and the union. It's not wrong, that's correct, but I can do better here. How? You have to, so the answer to this is A. The answer to this is also A. So these are called absorption laws. Absorption laws. So it means that if you want to understand the absorption law, the left-hand side is a very similar to distribution law, but one of the sets is repeating itself. If that is the case, the answer is the repeated set. Okay? First of all, let us try to understand this exactly at the level of your book. You should be able to understand it using a Venn diagram. Okay? So let us draw a Venn diagram to convince ourselves that this is indeed true. How should I do that? For example, I draw a big rectangle, call it the universal set, and I have two sets involved. So let me just, to consider the most general case, let me consider them, they are overlapping. Of course, you have to consider a lot of cases, but let us just consider this case. This is A and this is B. Okay, so now I want to color the region that represents the left-hand side. Okay, what should I do? First of all, I need to find A intersection B. Where is A intersection B? A intersection B is this part, yes? This part is A intersection B. Now, what I want to do after I found the intersection is the green region. Now you want to take that green region. Where is A? A is this whole circle here. And then you want to union the green region and the whole circle of A. What do you get? The union means the points which are either in the first one or in the second one. So I am interested in those points where they are either in A or in the green area. So where are they? A itself, yes? So this means that if you append this one to the whole one, don't think like numbers. You might think that, okay, I am having it 2 times. So I told you before that, for example, if you have A is equal to 1 and 2, and B is equal to 2 and 3, if I ask you what is the union, what do you write? You remember? You do not write 1, 2, 2, and 3. You write 1, 2, and 3, because in sets we do not have repetition of elements, yes? So that's exactly the same scenario here. So when I take A intersection B, I will get this one. If I take this green region and I get this whole circle of A and append them together, then I will get actually the whole A. Yeah, so this is from diagram point of view, it's very clear. But now, is it possible to prove it? The answer is yes, but you have to be a little bit creative here. So what I do, and this is, by the way, this what I'm writing is optional, so you don't need, this is enough for you. But if you want to understand that, so I would say that the left-hand side is equal. So I write something and I wait for you to see if this is true or false. Instead of A, you write A intersection the universal set, and then you write A intersection set B. First of all, I want you to understand this is correct. So what I have to do, you see, you compare this one with the left-hand side. This part is just the copy-paste of that part. But instead of A, I wrote A union, A intersection the universal set. Is that true or false? True. Because you might say, why you did that? Yeah, you need to, because I have some experience. I know what I'm going to have. I'm just foreseeing myself. But I mean, but you need to know what this is correct. A intersection the universal set is actually A. But now, can you tell me what is the next step I will go to do? I want to do. So I told you that you have some experience now. A intersection some set, here the universal set, union A intersection with B, yes?
A intersect U.
You can factor,
Yeah. You factor out.
Yeah, you factor A intersection out, yes? So you factor A intersection out, what happens?
U.
From this one, A, U is left. What is the sign?
Union.
Union. And from this set, B is left. Yes? And now let us continue. Can you say something concrete about this pair of brackets here? I have the universal set, which is unioned by some other set. What will happen?
It will become
the universal set, yes? So it becomes the universal set.
Yeah.
So this becomes A, copy and paste, intersection, copy and paste, but instead of that one, I am allowed to write the universal set. But what is the answer to A intersection universal set? A. So that's the proof, yes? And this is exactly equal to the right-hand side. So I told you, this is optional, so you don't need to know these. They are not hard, but this is not in the book. Okay? So anyway, if you have something similar to distributive law, but one set repeats itself, you don't need to even bother to use distributive law. The answer is the repeated set. Yes? It doesn't matter here, the answer will be the repeated set. Here, the answer is also the repeated set. By the way, this is something we already discovered here. We realized whatever this is equal to this. But we couldn't find the correct and compact answer. Now we found the compact answer is A. Let us do some practice and try to prove this one. Can you mimic this idea to prove this? I mean, the proofs are optional. You don't need to learn them for this course. But can you understand how should I act for proving the second one? So this is what I want to prove, yes? I want to prove that A intersection A union B is equal to A. I start from the left-hand side, but I want to wait for you. What do you think I will do here? So you need to just imitate the same kind of proof. Not exactly, but very similar, yes?
Do you mean that you could write A as... No, that doesn't work.
Mhm.
Right.
In that problem, instead of A, I wrote A intersection the unions. Why that was helpful? Because then I realized that A intersection here and then A intersection here are in common, so I can factor it out. Of course, in this case, I can also write A intersection U. That is not wrong, but this is useless. Why? Because here now I have A intersection, here I have A union, so I cannot factor something out. Is that clear? So even though if you write this is true, but that is not working. Okay, so instead of that, I need something. I want to have A, but instead of intersection, I want to have the union. If you think in that way, that is not hard, by the way. What do you think I will write here? Instead of A, I want, if possible, to write it as A union something. Yes? The empty set. Yes? So A union the empty set is the set itself, on the one hand. On the other hand, it is useful this time because what I see is A union and A union here. So this will allow me to be able to factor A union out. Yes? So what I would write A union, and then can you tell me what is left here now? A union, I take it out, the empty set is left, and then I have intersection. I took A union out, what is left is B. Okay, then how can I continue? You can say something concrete about this one even if you don't know anything about B. What that is?
The B intersect empty set is the empty set itself.
Is the empty set. There is no overlap. This is empty and this is B. There is no overlap between them. So this is the empty set. So I copy and paste this part and then I write the empty set. But you already know the answer to this even if you don't know anything about A. I have some set A, I union it with the empty set. The answer is A. Yes. So that becomes the right hand side. So this is the mathematical proof of these absorption laws. But as I told you that this part is optional. You really don't need to learn them if you don't like it. Okay. There is another one. So this book is not consistent because there is another law which is called De Morgan law. De Morgan laws. De Morgan, actually, laws. De Morgan's laws or something like that. I don't know, for some reason in the book they have asked you to prove it as a level 3 problem, okay? That is very strange because the attitude of the book is changing, okay? We'll talk a little bit about that one as well. But before doing that, let me test your understanding about the absorption law. For example, if I write this, can you answer this quickly using the absorption law? One of the versions of the absorption law is useful to answer this question immediately, or simplify it more. Yes, so what is I want you to learn, because by the way, this is a very important skill if you want to learn mathematics. Whenever you see a formula, you should be able to interpret it in your own language, English, Swedish, or whatever. What is the content of this? It means that if I have a set, I have written A as the name of my set, but you shouldn't stick with my notation. It means that if I have a set, union it with the same set intersection with another set, the answer is the repeated set itself. So it is, if you have this interpretation, then if I give this the name box, that is also box. So what I see, I have box intersection, box union another set. So that's also absorption law. So the answer is the box, and the box is A union B. So I mean that this is the way that you need to interpret the laws in mathematics, not in set theory, in anything. For example, when I write in Math 1c A plus B squared is A squared plus 2AB plus B squared, this is just a representative for a sentence. The sentence is that if I have the sum of two expressions squared, the answer is the first one squared plus 2 times the first one times the second one plus the second one squared. So it doesn't mean that I cannot use this rule for this. If I want to use this rule for that, then I can give this one name in my head, and then I have the sum of two things so that I can use the same rule. So this is all over mathematics. So whenever you have a formula, you should be able to interpret it in the language form. So I hope that you understand that if I ask you to simplify this, the answer to this is exactly A union B, because one of the base absorption laws, yes? Okay, let us now discuss about the De Morgan laws. So what are they? The idea of De Morgan law is that I give you two sets, A and B, you union them, for example, it becomes a new set, and then you take the complement of the whole set. We want to understand how this is connected to the complements of A and B. Okay, so in other words, we want to see that if this is true, for example, or not. Do you think that this is in general true? Okay, so let us understand that this is not in general true. For example, but by a very, very simple example. So let me take the universal set to be 1, 2, 3, and 4. For example, let me take A to be 1. Let me take B to be 1 and 2. Okay? For example, we want to check if this is true or false. Okay, let us calculate. Left-hand side. Left-hand side is A, which is this one, union with B. So the left-hand side is A, union B, totally complement. So what is the meaning of pairs of brackets here? It means that the priority is with this operation. So I have to union them first. So what is the union of this and that? It is 1 and 2, yes? So this is 1 and 2, because if I union them, if I append them, I'm not allowed to repeat 1 2 times. So that's 1, 2, and then I take the complement. So what the complement is?
3, 4.
Yes, complement of this set. I cannot ask you for the complement if I haven't given you already the universal set. Now that I have given you the universal set, for finding the complement, you have to take these out, and then 3 and 4 are left. So the answer to the left-hand side is 3 and 4. Let us now check the right-hand side. What is the right-hand side? A complement means one complement, and then union, and then I have 1 and 2 complements, yes? Let us check. What is one complement?
3, 4. 2, 3, 4.
2, 3, and 4. So it becomes 2, 3, and 4. Union. What is the complement of 1 and 2?
3, 4.
3 and 4. And then I want to union these two sets. What do I get? I get 2, 3, and 4. Yes? And then you see that the left-hand side is not equal to the right-hand side. Yes? So this is not correct. So definitely this is not De Morgan's law, yes? Because that's not a law at all. It's not correct. But this is probably a little bit close to intuition. If you are not that experienced, you might think this is true. But I hope that you understand that you cannot rely on your feelings. Yeah, mathematics doesn't care about your feelings at all. So this feeling is not correct. But the point is that is there any correct version of that, or it is not? And then we're going to actually realize that yes, there is a rule going on. The correct rule is this. If I have two sets, A and B, I union them, and then I take the complement, the answer is A complement, B complement, but not union, intersection. So that is the correct rule. So this is why it was not working in general. That is the correct rule. But let us, by the way, check if this is correct or not. The left-hand side is still the left-hand side, so it is 3 and 4. But instead of unioning them, De Morgan actually tells us that intersect them. So what do I get after intersection between these two? I get 3 and 4. And 3 and 4 is exactly the left-hand side. So this is the De Morgan law. So if you have the union of two sets and you want to complement it, you are allowed to complement each one of them, but you have to turn union to intersection. And the opposite way around. So A, B, I intersect them first, and then complement it. The answer is again A complement, B complement, but the intersection should turn into a union. So these are De Morgan's law, yes? De Morgan's laws. Yeah, I proved this one because that's one exercise in the book. I told you that there is not a consistency with the way that they present stuff here. Before proving it, let us understand it from Venn diagram point of view. For example, one of them. It's always good to practice like this. So if I want, for example, let us concentrate on the first one. So I have this universal set, and then I have two sets. The most general case is consider they overlap, yes? Okay, I want to convince myself for an equality, so I have to draw two diagrams so that I can compare them. In principle, they have to be identical. Okay, so it is hard for me to draw it by hand, identical, but I hope you can imagine this is supposed to be an identical copy, a replicate of this one, okay? So you can imagine this is the same thing, exactly. Okay, let us concentrate on the left-hand side in this picture to represent this one on this picture and represent this one on this picture and then compare it. So can you tell me where should I look for? This is A union B and then complement. So where is A union B? A union B is this one. So A union B is everything inside this border. Yes, everything inside this border is A union B. Yes, is that understandable? But I am interested in the complement of that. So it means outside this border is the complement. So if I want to color it, so this is the orange one is actually, this is the left-hand side. Yes, so I found A union B, and then I looked outside that region. But now for this one, this is a little bit more complicated. I don't know how to draw it. So I have to find A complement and B complement and then intersect them. Yeah, it is a little bit messy, but hopefully you understand at the end of the day. So where is A complement? A complement means outside A. So outside A is here. So let me color it horizontally. I have to be careful that I'm not allowed to be inside A, but I don't need to be careful about if I am inside B or not. What I have to be careful is that I have to be outside A. Yeah, hopefully this is understandable for you. So if the black part is A complement. Now I change my color, for example, to green one, and I find B complement. B complement means outside B. Okay, so let me just do it vertically with green. Outside B, I have to be careful to be outside B, but I don't need to be careful if I am inside A or not. Yes, so outside B, this is outside B. So the green one is outside B, B complement. Yes? But now what I want the overlap, the intersection between these two. It means that I am looking for those points which are colored with two colors, yes, black and green. So the black part is A complement, the green part is B complement. I am looking for the overlap between the green and the black one. But I hope that you agree that it's exactly this area, this region, yes? The points, so this part is not included because it is not colored at all. This part is not included because it is only colored with green. This part is not included because it is colored only with black. Okay, so what is inside this border is not acceptable. But on the other hand, outside this border, everywhere is colored with two colors, green and black. So that is exactly the same place, yes? You have to convince yourself that this is indeed true. This is, of course, not a mathematical proof, but that is very good, actually, to understand what is going on. I really recommend you to do one more for yourself to understand that this is also true. But now let me try to prove it, because I saw that this is a level 3 problem in the book. Okay, let us concentrate here. If I want to show that these two sets are equal, what should I show? I should show that whatever is in this set, it's also in this set, but that is not enough, because this means that this is a subset of that one. Yes, but I should also show that whatever is here is also here. Yes, if I can show this, I am done. So I would say that let x be an element, whatever you want, let x be in A union B complement. We show that x belongs to the right hand side. Yes, is that clear? So I am assuming that I have an element in the left hand side. I want to show that the same element is also an element of the right hand side. I hope that you agree with me that this is not enough. Because if I show this, it means that whatever is in this one is also in that one. It might happen that this includes more elements. But I have to show that the other way around is also true. But for the time being, that's enough. Okay. Now I want to help you to help me. Okay, so X belongs to A union B complement. What is the logical consequence of that? If I give you an element in the complement of a set, what can you conclude? The most natural thing, yes? What can you conclude? If X belongs to the complement of a set, it means that you should be able to say yes?
X doesn't belong to the set.
Yes? Because if X belongs to the complement, it does not belong to the set itself. Yes? This is something not very hard to understand. Yes? This is a new language, I agree. Might be you're a little bit confused, but I mean, this is an immediate consequence of the definition of the complement. But now the translation of this is a little bit hard. Yes, let me go back and ask your opinion about that. We talked about this before. So if X belongs to A union B, what is the immediate consequence of this? By the definition of the union, X belongs to A or X belongs to B. Yes? But you remember, now we want to translate the other way around. If X is not in A union B, what is the conclusion? That is the conclusion that I want to write here. The diagram is here. Assume that X is not in the union of A and B. This green border, inside that is A union B. If I tell you that I have an element which is not in the union, what can you conclude about X and A and about X and B? X is not in the union. For example, X is somewhere in this orange part. When it is not in the union, it is somewhere here, yes? So what can you conclude about X and A? What can you conclude about X and B? Yes?
X does not belong to A and X does not belong to B.
And, that is important. Yes, exactly. So X does not belong to A. The important thing that it turns out to and. Yes? X does not belong to B. Is that understandable? When I say X does not belong to the union, you see that this is the union. X does not belong to the union. It means X is somewhere in the region, in the orange region. But this is clear that if X is in the orange region, it is neither in A nor in B. Okay? In logic, we say X does not belong to A and X does not belong to B. Now, if I tell you that X does not belong to A, then you conclude X belongs to where? If X is not in the set, where is it?
The complement.
It is in the complement. So X belongs to the complement. And if X does not belong to B, where is it? In the complement of B. Now, the interesting thing is that, you see, that's the reason that De Morgan law did not work if I keep this union and that union. Because now, this is not or, this is and. Okay, so if X belongs to A complement and simultaneously belongs to B complement, it is in the overlap of A complement and B complement. And overlap means intersection. Yes? So I chose an element, an arbitrary element, from the set on the left, and I convinced myself that exactly the same element is in the set which is sitting on the right. What does it mean? It means everything here is also included there. But I hope that you understand this is not enough, because this might be a bigger set which contains everything, but it has something new in it. We want to show that no, this is not the case. This doesn't include any other elements other than these elements. Okay, so what we do, so if you want, I can write some phrase here. So far, we showed that this is the thing we have showed so far. A union B complement is a subset of A complement union B intersection B complement. This is not correct, this is not wrong, but this is not complete, because De Morgan's law actually demands more. You want to prove that they are really equal. You don't need to write this one. So what you write now, what should I do? This time, so we now let x belongs to the right-hand side this time and show that we now let x belong to this and show that x belongs to, oh sorry, this is not union, this is intersection. X belongs to A union B complement. Okay, now can you tell me what to do? So I have assumed that X is in the intersection of these two sets. I want to convince myself that this exact X also belongs to this set. Okay, so let us try to understand this problem. X belongs to A complement, intersection B complement. What can I conclude from this one? X is in the overlap of two sets. What is the conclusion if I want to get from that? X belongs to the intersection. What does it mean? Yes? Not A and B. This one and that one. Yes? Because this is my set, this is another set, and this is the intersection. I know that X is in the overlap between these two sets. What does it mean? It means that this X is an element of the first set, and it is also an element of the second set. So this means that X belongs to the first set, and X belongs to the second set. Yes, just let me make sure that you understand. Do you agree with this conclusion? Yes, X belongs. Okay, now what can I say to this one? If you tell me that X is in the complement, I am allowed to conclude something immediately. What is that thing? X belongs to the complement of the set. It means X does not belong to the set itself. Yes? And then I have and X belongs to B complement means X does not belong to the set B. Okay, let me ask you something. I want to write something. I want to write X. This question mark I want you to answer. And then I want to write A union B. How do you write this? I want you to put a symbol there, which is true. X is not in A and X is not in B. How X is related to A union B? Is it there or is it not there or is it not certain? No one else? Yes?
It does not belong.
Yes. Do you agree? Because you are telling me that X is not in A, is neither in A nor in B. So there is no way for this X to be in the union. Because if X is supposed to be in the union, it has to be at least in one of these sets. Yes, is that understandable? So that's pure logic. You need to play around with these sentences until you get experience. So X, so this question mark is does not belong to. Yes? Because let me tell you in the other way. If you say that X belongs to A union B, it means that it is either in A or in B. But you are telling me, on the other hand, that X is neither in A nor in B. So there is no way for this X to be found in A union B. But now, can you tell me what can I conclude now? X is not in a set. Definitely this X is in somewhere. Where is that? The complement of this set. Yes? So I started with an element, a representative element of the set on the left. and I convinced myself based on logic and definition that this x also belongs to that one. So what does it mean? It means that A complement intersection B complement is also a subset of A union B complement. So once we showed that this one is a subset of that one, another time we showed this one is a subset of that one. So if these two happen simultaneously, it means that they have to be equal. Yes? So that is, this is good. It is not, by the way, very hard for your level of studies, but anyway, there is no consistency, I would say, in the book. So this is the mathematical proof of that, of the first De Morgan law. Okay, so to practice this way of proving these things mathematically, let us prove the second one together, okay? We want to prove this one now. Okay, so now you know what to do. So what I have to do, I would say that let me clean everything here. So let me practice this again. Practice this together. I want to prove that two sets are equal. Once I have to convince myself whatever here is here. This is not enough because this will guarantee the left one is the subset of the other one. I should also convince myself whatever here is also here. So that is the logic. If you want to prove something, two sets are equal mathematically, you have two ways. One way is algebra of sets. Okay? So if you know the rules of algebra, you can algebraically solve them, but there is no way that I can do this algebraically here. There is no other rule. This is one of the fundamental rules itself. So whenever you want to prove such a scenario, you have to actually use this method. Okay, so let us just do that. I would say that so what should I do? Let X be in A intersection B complement. Okay, so the diagram of this is not on the board. Might be you need to have a little bit of challenge in understanding this logically, okay? So let X belongs to this. We show that what? Okay, tell me what I want to write here. We show that what? What I want to write? Yes?
X belongs to the complement UFA and union the complement of P.
So you are reading this?
Yes.
Yes. So this is read A complement union B complement. Yes? Is that clear? I want to show this. I assume that this X is in the left-hand side. I want to show that it is also in the right-hand side. Is that understandable? So let us try to understand it. Okay, I will start from this. You are telling me that X belongs to the A intersection B complement. What is an immediate consequence of this? What is that? Yes?
A does not belong to A and A does not belong to B.
No.
No, X.
No, immediate consequence. That is coming later. Don't be in hurry. When I know X is in the complement, it means that? Yes?
A does not belong to a union.
Yes, you have to write this, but because you were in hurry, yes? So you have to write that X is not in the U intersection. Yes? X belongs to the complement of a set. Definitely X does not belong to the set itself. But I want you to translate this, okay? What can I conclude here? Okay, so what you are saying is that you say that X belongs to A. What did you say?
A does not belong to A or B.
Or X does not belong to B. So that's the point. Do you agree with her or not?
No.
This should be or it should be and. Okay, be careful about that. I want you to understand. By the way, this is not mathematics, this is logic. And mathematics is based on logic. I will not be able to teach you logic. So because if you don't understand these things, when you do programming, you will have a lot of bugs in your program. Yes? Because you don't appreciate the difference between and, or, and things like that. That's why I'm saying that I will not be able to teach you. Of course, I can convince you, but at the end of the day, you don't need a teacher to teach you the logic, because all human brains are actually acting according to the logic. Yes, and mathematics is, by the way, based on logic. So I want to make sure. Do you agree with or and? Think about it.
Or.
Is it or and? Is it or and?
Or.
Yes.
Yes.
Can you defend that?
The intersection between A and B means that the middle section.
So, okay, let us draw a picture. So what you are saying is that this is good for convincing yourself. Of course, this is not the whole story because I am not considering everything. But anyway, this is not better than nothing.
Yeah.
So this is A intersection.
Yeah.
What I am telling you is that X is not in the intersection. Yes? So what does it mean?
It can be in A or B.
Yes. So it can be here.
Yeah.
So it is in A, but not in B. It can be here, which is in B, not in A. Or it can be completely outside, which is neither in A nor in B. So what you said is correct. Yes? So X does not belong to A or does not belong to B. Be careful. You cannot guarantee that. Because when I write this, it means I am guaranteeing that this happens if this happens. I am saying that this implies that. When you say this implies that, it means that whenever this happens, 100% this will also happen. But this is not the case, yes? Because let me just tell you, X is not in A union B. Do you agree this is one possibility for X? Yes, X does not belong to A intersection B. But is it correct to conclude that X is not in A and X is not in B? No, because X is in A. So if X is not in intersection, it is not 100% guaranteed that X is neither in A nor in B. But it is 100% guaranteed that X is either not in A or not in B. Extremely important to write or. Yes? Understandable or not? Yes? Okay. Now continue. The continuation is actually very simple. If X is not in A, what can I write?
X belongs to the complement.
To the complement. Or I copy and paste or. X does not belong to B means where? X is in B complement. Yes? Now let us interpret this again. X is in one set or X is in another set. Okay, where is this down? X again. Okay, so where is this X then? I want to write some set which is guaranteed to contain X. What that set is?
Universal.
Of course, universal is more than that. Yes.
A complement union.
A complement union B complement. Yes. Yes. So I know something. I know X is either in this set or in that set. Definitely this X is in the union. Why? Because that's the definition of the union. Is that clear? Okay. By the way, this is abstract mathematics. So mathematicians are always talking these kind of things, yes? So they are a little bit crazy, I know, but this is the way it works. It's not hard. By the way, it's a very good practice to practice your logic. Is that clear? So it means that I took an element from this set and I was able to convince myself based on logic and based on definitions of intersection, union, and complement that this X also belongs to this one. But is it finished? No, because I was able to convince myself everything here is there. But there is no guarantee that this contains more elements, yes? But I want to show that no, this is not the case. So far, we showed that what? We showed what? We showed A intersection B complement is a subset of A complement union B complement. Okay, we want to prove the other way around. Okay. The other way around means this time you take an arbitrary element from this one and then convince yourself that is also in this one. Okay, so we say that now, let X belongs to A complement union B complement. We prove that X belongs to A intersection B totally complement. Okay, I want you to help me. Okay, so I start from my assumption. X belongs to the A complement union B complement. What is the immediate consequence of this? What does this one imply based on the definition of the union? I know that X belongs to the union of two sets. What does this mean by definition of the union? Yes? Okay. X belongs to the union of two sets. What does it mean? It's not hard, by the way. Yes?
X does not belong to...
No, just don't jump into the conclusion. X belongs to the union of two sets. I'm just repeating it. This means forget about the names. X belongs to the union of two sets. What is an immediate consequence of this? Yes? Yes. X belongs to this set or that set, whatever the names are. I don't care about the names. X belongs to the union of two sets. Definitely X belongs either to the first one or to the second one. You see, I am not calling them A complement, B complement, yes? I know that X is in the union of two sets. Whatever the names are, I don't care. So X belongs to the union of these two sets. It means X belongs to the first one or the second one. That's the, but if someone asks you why, you would say that is exactly the definition of the union. Yes? So X belongs to A complement or X belongs to B complement. So don't jump to draw conclusions. Now I can hear from you. X belongs to the A complement. If X belongs to the A complement, definitely X does not belong to A. So this means that X does not belong to A. This is or. X belongs to B complement means X belongs to where? Is X does not belong to B. But you need to have an eye what you want to conclude, yes? You want to convince yourself that X belongs to A intersection B complement. So I need intersection somehow. But let me ask you something. What can I conclude from here? X, question mark, I want you to fill it up with a symbol, and then I want to write A intersection B here. How should I fill it up? I know that I have an element X which does not belong to A, which either does not belong to A or does not belong to B. What can I conclude about this X and its situation with respect to the intersection? Yeah, I want you to think about it. Might be I'm confusing you. Yes?
X does not belong to A or something.
So you mean that I should write this? This one you mean? Okay. How many of you agree with that? No?
I think it belongs maybe.
It belongs maybe? No, 100%.
Yes.
Okay? 100%? Yes or no?
80%.
So mathematics is black and white, 0 or 1. X does not belong to A, or X does not belong to B. You said that I can conclude that X does not belong to A intersection B, and then Mario, you said that X belongs to A intersection B, yes? Okay? Which one is true? This one? Yes? And this one is true. Yes, because when you say that for X to be in A and B, it has to be in both of them simultaneously. Yes? But this is not happening. Because when you say this is the case or this is the case, it means at least one of them has occurred. This is the meaning of or in mathematics. It means at least one of the situations have been met. Has been met, yes? So this means that X does not belong to A or X does not belong to B really implies that X does not belong to the intersection. Because for X to be in the intersection, it should simultaneously be in A and in B, but it is not in at least one of them. So that's correct. Okay, and then if X is not here, where is it?
The complement.
The complement, yes? So X belongs to the complement. So that is finished now, yes? Therefore, what happens? A complement union B complement is also a subset of A intersection B complement. If you really want to write it very precise, you need to give it a name, number one, and then you give it a name. I forgot to do this in the previous, I just talked about that orally. So then I write 1 and 2, and then from 1 and 2, you conclude that they are the same. So therefore, from 1 and 2, we have they are equal. Yes? So this level of the exercise is different from other questions, but this is in the book. Okay, so this is why I talked about that.
Where did you put the one?
Here is 1.
Yeah.
And here is 2. Okay, there is one more operation. I want to also talk about that one. It doesn't, but I will practice a little bit more about set. Officially, it will be finalized today, but I want to give some more examples next time, which will be after the break probably. So there is another operation called subtraction, or the difference of two sets. So we had complement, we have union, we have intersection, and the last operation I want you to learn about the sets, which is also in the book, is the difference between two sets. Okay, so what is that? The difference between two sets, assume that I have a set A and I have a set B, I subtract them. In some books, I don't remember which one is using in your book, they use this symbol. I'm not very, it's not very comfortable for me. I use this symbol as before, but this symbol, the reason that they write it like that might be, this is more logical, yes, because this operation is the same minus sign that we use for numbers, but these are not numbers, these are sets. So it might be this is more logical to use a different symbol for that, but let me just use the same symbol I'll use. It's also very, by the way, very common. What is this? If I have two sets and I ask you to find the difference between them, it is not like the subtraction of numbers, because the sets doesn't necessarily include numbers at all. They might have letters, objects, whatever. So when I say A minus B, it means that I am interested in all elements from the universal set, of course, with some extra property. The extra property is that X belongs to A and X does not belong to B. So when I say A minus B, it consists of all elements which are in the first set. Be careful. A is the first set, B is the second set. Okay, so for example, if I want to draw a Venn diagram for you to visualize this, so can you tell me where should I color? For example, in this picture, this is my universal set. Let me consider this to be A. Let me consider this to be B. I want to color which region I should color to represent A minus B. The points should be included with two properties. That point should be included in A, but it should be outside B. It should not be in B.
Coloring A except the intersection between A.
Yes, so this is exactly what you need to visualize when you think about A minus B. Yes, this part is A minus B. For example, if I ask you, can you color B minus A? Do you think it would be the same or it will be different?
Different.
It will be different because now this is the first set, this is the second set. So how do you read it in English? It means I am interested in all elements which belong to the first set but does not belong to the second set. But here the first set is B, the second set is A. So if I ask you to color B minus A, where do you color? Everything in B which is not part of it, part of the A. So hopefully you agree with me, this is the representative of B minus A. So this is B minus A. For example, let me give you some more concrete examples. So I give you A to be 1 and 2, and I give you B to be 2 and 3 and 4. Okay, can you tell me, if I ask you to write A minus B, what do you write? If I ask you to write B minus A, what do you write? A minus B, it means all elements which are in A, but they are not in B. So what is that? Yes? So what should I write? 1. 1 is in A, it is not in B, so it is acceptable. Is 2 acceptable? No, because 2 is here, but also there, so there is nothing else. It's a singleton. Yes? Okay, now can you tell me what is B minus A? When I say B minus A, I am interested in elements of B which are not in A. So I go to B first. Am I allowed to write 2 here? No, because even though 2 is in B, but it is also in A, I exclude that one. So 2 is not acceptable. 3. Yes. Because 3 is here, but not here, it is acceptable. What about 4? Yes, it's also acceptable. But I have seen some students suddenly write 1 as well. But this is not correct, because when I see B minus A, I have to only care about the elements of B first. Okay, so don't write this anymore. So that's the answer. And again, you see that they are not equal. So we can say that this difference operation is not commutative. Okay? So what do you think will happen here? If I give you A to be 1 and 2, I give you B to be 1 and 2 and 3. Okay, can you tell me what is B minus A? What's the answer? Only 3. And if I ask you what is A minus B, what's the answer? What's the answer?
Empty set.
Empty set. So you made that mistake, yes? So this becomes the empty set. Because when I say A minus B, I am interested in all the elements of A which are not in B, but there are not such an element, yes? Because can I pick 1? No, because 1 is also in B. I do not pick it. Can I pick 2? No, because it is also in B. So is there something that I can pick from the elements of A which are not in B? No, there are no such an element. So A minus B is the empty set. Yes? Is that clear or not? Okay, so now for example, what do you think will happen here? A minus A. I have a set, and I want to subtract the set from itself. What do I get? Yes, I hope that that is acceptable for you, yes? Do you agree? So A minus A is this empty set. It's clear, yes? Because you want to choose elements from A which are not included in itself. There are no such an element, yes? What do you think this will happen? A minus the empty set. Sorry. That's A. Yes? Is that clear for everyone? Yes? But might be this is more a little bit problematic. What if I write empty set first? This is the empty set again. Don't get confused, yes? Because I am interested in all the elements of the first set which are not included in the second set. But is there any element in the first set at all? No, so there's empty set. One more thing. What do you think this will happen? The universal set minus the set A. It means all the elements which are in the universal set and they are not in A. Yes? It becomes the complement of A. Yes? Is that clear? Because when you write U minus A, it means I am interested in elements of the universal set which are not in A. That is exactly the definition of the complement. Yes? So the lesson is officially finished, but I will continue with more examples the first time we come back actually. Yes, because that is the last time we have Math 5 this week. Yes? Okay. Any questions? Okay, thank you.